I don't know what meeting is. People who aren't here. Apologies about that. I thought I had that posted. That's one of my Friday jobs, is to get next week's lectures all posted. I would do it as a recurring thing, and maybe for this class I will from now on. So as you know, the office hours are already recurring. I could make this recurring every Monday, and that way I make sure I get the record going automatically. Before we go into lecture material, how are things? I think the teams are having some teams are having some issues, really struggling, and some teams are having normal teams struggling issues. How are things? What do I need to know? What do we need to do differently? We're all friends. You can say it. Let me ask a more specific question. Has every team met with a TA? Every team that's represented here anyway. Have you held a meeting with a TA?
Our team had a demo the end of sprint one with Luke.
Last Monday?
I think so.
Last Monday. Let's see, are you meeting at 7 o'clock tonight again, your team?
We usually meet around 5.
Oh, sorry, I didn't realize you were asking me.
Yeah. Sorry. Hold on. Okay, Suarez South. Okay. Yeah, I'm really struggling with nailing down team meeting times. And as you know, I posted that survey, which everybody filled out. And sometimes I can't make, and some teams are like, well, we often meet on Wednesdays, but we don't always meet on Wednesdays, right? So people are being flexible, which I think in some sense you have to be, but in another sense, regularity in meeting times is really helpful because you get in the habit of meeting. Let me see. So anyway, you said today at 5?
Yeah, usually it's every Monday, Wednesday, Friday at 5. One of our teammates just got a new job though, so that might change because his hours are changing.
Yeah. So as you can expect, you're having trouble coordinating, a little bit of trouble coordinating one team, and I've got 12. So it's been more of a struggle than I thought it was going to be, just to figure out how to get a hold of you guys and watch what you do, watch what the team is doing, and give advice as to how to move forward, which is not good, right? So that's a problem that I'm still working to solve. I did get to see a demo from one team. I thought overall it went fairly well, but what I really want to see next was like a sprint review meeting or a sprint retrospective, right? I want to see how people behave in a sprint planning meeting, that kind of thing, without me saying that much during the actual meeting itself, and then giving feedback afterwards. So we need to figure out, if you guys have a great idea as to how I can quickly and readily do that, that's fine. One thing you could do is, if you give me 2 or 3 days notice, our team is going to do sprint review on this date, and here's the link, and give me 2 or 3 days notice and send me a Canvas message, that would work out fine too. I'm composing an announcement to talk about different issues, because here's the issues that I have listed. Grading status, I'm going as fast as I can, but I'm going to have, I think I'm going to always be about a week beyond where I want to be. So I got all the sprint 0 stuff done, and we'll do the sprint 1 stuff. We'll be working on, I'll be working on this week. Some of that I might have to push down to the TAs it might be where the TAs assign the grade and I do, give feedback or something like that. So be aware that I am not forgetting you or abandoning you. I'm just always a little bit behind where I want to be on my grading. It's a virtual course, and so this is a topic, right? Grading status is a topic. Virtual course and personal responsibility is a topic. meeting with the TAs and instructors. I think we need to do that in order for you guys to feel that you're actually in a course. Scrum guide is a topic. I'm just running through my topics right now. Guide to running a productive meeting is a topic. And meeting outcomes for each of the different meeting types is a topic. Am I missing a topic? If you think of one, send me a message in Canvas. If there's a topic that you'd like discussed, not so much about the technical details of how Scrum works or how to do programming, but how to get value out of the course. Right? So if you're thinking of a topic that you would like to see addressed, then send me a Canvas message. Okay. As far as being productive, let me just spend a couple minutes on that again before we get into the course topics. Because, well, first of all, Scrum Guide, I've linked to it in a couple different places. I'm going to link to it again in this announcement. If you have not read the Scrum Guide, really read it. Read it. It's so helpful. It speaks with great clarity as to what should be happening at every phase of your sprint. You know, not a bad thing to have. You know, in my day, we would print it out and bring it to the meeting. You guys always like to do things digitally, it seems, right? Not a bad thing to have up on one side of your screen. So as you're in a meeting, you can check against it. Oh yeah, did we do that? Did we do that? Did we do that? As far as running productive meetings, I think some people have a wide variety of experience with this. So some of you people that are in student clubs and organizations may have had experience running meetings and had really good role models on how to run meetings. But how do you run a good meeting? What are some of the elements of a good meeting?
I would say a good example is what you're doing right now, and being comfortable with long, awkward silences to give people the chance to like actually think of something and respond. So you're not just like, you know, bulldozing through a meeting on your own.
Right. Yeah, I've learned to become very patient, and I can usually out awkward my students, right? I can withstand long silences longer than they can. So yeah, think about this for a few seconds. What are the elements of a good meeting?
Having everybody participate.
Okay. Now, yeah, and that's right. First of all, so I'm going to talk about that. I call it the one meeting policy. When I worked at NASA, I actually worked for Boeing, contractor to NASA. When I worked at NASA, they had a terrific policy, the one meeting policy. You're in a room with a bunch of people, and the meeting, here was the purpose of this meeting, here's what we are to talk about, and the person who was in charge of that meeting would call on people one at a time to do their whatever they needed to contribute to the meeting. If people needed to say something, that one person would call on that one person, and those were the only people talking. And if you even leaned over and whispered to your neighbor something, immediately that person who was in charge would say, "One meeting, please." It was the one meeting policy. One meeting, please. So here you are in a virtual environment. And I know I've heard, and I fully, I was not shocked at all that some teams are holding meetings, but one person's playing a video game while they're, quote, in the meeting. Well, screw that. One meeting, please. And whoever is in charge of the meeting is allowed to say that. One meeting, please. Ditch the game or leave the meeting. You're allowed to do that. And you should do that. The fact that we're in a virtual setting means that personal discipline is going to make or break the course for everybody. So you're allowed to enforce the one meeting policy. So that's how you get everyone to participate, Tyler. What else? That's a good one.
I guess another one can be trying to get all your goals done that you like had for the meeting.
How do you know what the goals are?
That you come up with them
Right, by the way.
beforehand.
Yeah. So every meeting has an agenda or at least a checklist. Every meeting has an agenda or a checklist. You don't just meet just to meet, right? Oh, we're supposed to meet 3 times a week. So here we are, right? What do? I don't know. Right? You have an agenda. And that agenda has agenda items or a checklist, however you want to frame it. And just like you have one meeting at a time, you discuss one thing at a time. So here you are on agenda item number 2. Everybody is going to talk about agenda item number 2, or they're not going to talk. And if someone starts talking about, oh, I wanted to say something about agenda item number 4, then whoever is the facilitator of that meeting gets to say, okay, that's great. We're going to wait on that because it's later on in the agenda. We're going to talk about that when it's time to talk about that. The point is to try to, if you don't do that, it's great to have what I'm doing now, tangential discussions. It's great when you're having dinner with friends to have these long meandering conversations that go all over the place and end up nowhere. That's fun, but it doesn't make for a good meeting. So a good meeting is, here's the agenda items, and we're going to follow this first item. And you do 2 things. You try to resolve that agenda item. You try to. But also remember, we want you to be good time managers. So you time box your meeting. Maybe your meeting is 2 hours long and this agenda item has 15 minutes on it. If 15 minutes is up and it hasn't been resolved, you are allowed to say, we are ending discussion on this. We're going to approach it again at the next meeting. But if you have resolution on it, then at the end of that item, we clearly say, don't say, oh, we have that resolved, because you might have actually 3 or 4 different resolutions and not know it. You have to say, we have this resolved. This is what we are going to do. We are going to take steps 1, 2, and 3. Do we all agree? And that way, everybody hopefully has an understanding that you have all agreed to do steps 1, 2, and 3. Both of these things that I'm talking about implies, by the way, that there's somebody, and I'm going to say a gentle term, a facilitator of the meeting, right? I don't want to be, right? The teams don't really have team leaders per se. And so I don't want to say there's someone in charge or there's a leader in the meeting, but there is a facilitator in the meeting, which is someone who is supposed to be there to make sure the meeting goes well. I would say for your scrums meetings, the scrum master, that's that person's job. For the other meetings, the product owner would be a good person to do that job. And all of you are going to rotate around those roles. So if you see that somebody's doing something that you like in a meeting, you can mimic that when it's your turn to become the facilitator for that meeting. I worked with a guy years ago named Bob Kaplan, and this was back when all of us were in cubes. We were in cube world in the offices, and his cube was next to mine. And I thought he had a management technique that was wonderful. He would have these meetings from different departments. They'd all sit there for an hour, 2 hours, whatever. They'd agree on a plan of action. And literally, as they're walking out of his cubicle, he would point to each one and say, you're going to do this by Tuesday. You're going to do this by Wednesday. You're going to do this by Tuesday. You're going to get back to me tomorrow. And literally tell them, remind them as they're walking out the door, this is exactly what you have agreed to do and when you agreed to do it. That's great clarity. That's the kind of clarity you want after your meetings are done, so that everybody leaves and they know, okay, I know exactly what I need to do and exactly when it's supposed to be done by. So those are things that run a good meeting. Basically, you have a facilitator, you have an agenda, you stay on topic with the agenda. If people are, in fact, we had a department meeting last Thursday, and my department chair skipped an agenda item. So I jumped in and said, you skipped an agenda item. He said, oh, you're right, went back. So, you have an agenda, you follow the agenda. You have clear outcomes, and then you repeat those outcomes at the end of the meeting so that everybody gets a chance to say, whoa, wait a minute, that's not what I heard. Or, yes, that is what I heard. And you have the one meeting policy. That will help your meetings, and it shortens the meeting, because you don't want to listen for 15 minutes. In a meeting, you don't want to listen to 15 minutes about someone who went down to the beach and found a great place to eat. That's not the meeting topic, right? So that's before the meeting, after the meeting, that's all great. Okay. So that's one of the things I want to see when I get to see how you interact as a team, how that all works out for you. Okay, and then for the meeting outcomes, I'm going to give you, you can go to the sprint guide, the Scrum guide and get this, but I'm going to give you reminders and summarizations, is that a word? Of the sprint planning meeting, the Scrums, and the and actually working meetings. And so I won't repeat them here. However, I do want to talk about two of them. One is there is a meeting that we never talk about called the working meeting. And it's not even a meeting. So here's how it goes. In the real world, when you do Agile Scrum, one of the things that is critical to it is this notion of co-located teams. And the idea is a lot of stuff that we used to do in documentation form gets done through co-location, because rather than having to write something down in a document so that someone else can read it at another time and place, if we're in the same room and we're agreeing on it together, that's kind of the documentation, or that's how, I should say, that's how the information is transmitted. It's this osmotic communication, they call it. Well, we don't have that in the virtual environment. So what's happening with some teams is they meet, they agree on tasks, and everybody goes off in 4 different directions, northeast, south, and west, and they do their work individually. Well, that kind of breaks down the notion of the team in the sense that you have 4 people doing jobs as individuals that maybe contribute to the team, but that whole team sharing of information isn't really there. So I suggest the following. When you have your Scrum meetings, remember the job of that is to say, here's what I did yesterday, here's what I'm going to do today, here's what you're right. And since you're not meeting every day, it might be, okay, we meet Wednesdays and Fridays, so here's what I'm going to do between Monday and Wednesday. I'm going to code up something, or I'm going to do something. When that person says that, what's wrong with saying, oh, what time are you planning on doing that? If you're going to do it between 8 o'clock and 10 o'clock on Thursday, I can jump on Discord with you, or we can be in Zoom, and we can be in the same virtual space with a shared screen. And while you're programming, I can watch, keep one eye on what you're doing and one eye on what I'm doing, and we can keep swapping the screens back and forth so that we actually have the sense of a shared space. I think people are uncomfortable with that. Like it's like writing code looking over your shoulder. But the goal is to get comfortable with that. The goal is to work in a shared space. So consider that kind of an idea. So that's one thing I would like to talk about. And then the other thing is in the sprint planning meeting, I think, let me ask you this. What are the outcomes of your sprint planning meetings so far? You've had 2 of them, is this true? What were the outcomes? What was done what was there at the end of it?
We had our sprint backlog, so everyone kind of knew what tasks they had to do during the sprint.
Okay, so you have a sprint backlog, and these have tasks. Some tasks are maybe documentation tasks, some tasks are coding tasks. Every task is assigned to a human, and there's hours estimated.
Yeah.
Anybody else? What did you end up with? Oh my gosh, only one team had an outcome.
Our sprint planning was more figuring out who was going to do what. It was hard to say how long each thing would take because you're kind of going into this project fairly blind. I'm not very experienced with really any of what we're doing, and I don't think anyone else on my team really is either. So we're just kind of trying to take it one step at a time.
Okay, well, first of all, that's all good stuff that I'm hearing. The fact that you're taking, the goal is always to take a big problem and break it down into smaller problems. And then it can be difficult to do time estimates on things. That's part of what happens at the sprint review, is you can start in sprint retrospective, right, is you can do adjustments to your backlog items based on your recent. So that's all positive stuff I'm hearing. If you're hesitant about your experience level and ability to get some jobs done, that's okay. That's, if you were, otherwise you may not be taking this course. Right? That's one of the goals of the course is to get more practice. So that's all positive stuff.
we're basically just since we are having trouble meeting, like we're still meeting, it's just not like it's nowhere near daily. So we're just keeping each other up to date with messaging.
Okay.
And I think that's working out really well.
Okay.
It's the best substitute we can get for a meeting. We're getting a lot better this sprint with actually having more frequent meetings though.
Good. That's part of the retrospective. Good. Okay. Yeah, the asynchronous messaging, I've tried that before and I've never been happy with it. It's sometimes it's like the communication mode of last resort. It can be really tough. There's something magical about people in the same space at the same time, whether it's virtual or real. Some good interaction happens. It's probably just because we're social creatures. I don't know. All right. So how long did your sprint planning meetings take? TJ, roughly how long did your sprint planning meeting take?
I want to say it took us about an hour.
Okay.
And then after that, we did some small updates to our documentation.
Okay. And you did that as a group.
And I want to say that was about it.
By the way, documentation can be a task on your spreadsheets that are not assigned to user stories. And Rose, roughly how long did you?
Yeah, we're definitely including those on this sprint because that was a lot of time that we didn't account for last
Right.
one.
You want to account for all the time that you believe this will take, and documentation takes time, right? Rose, you said you guys had the sprint planning meeting. Roughly how long did that take? What's your?
I think it was also about an hour.
About an hour, yeah.
What do you guys think? I think it was something like that.
Okay. And at the end, everybody knew what they had to do. And I'm going to focus on coding right now, on the people that were doing programming. Everybody should be doing programming at some point. I think some teams are starting out where people who are less comfortable with their programming skills are doing documentation up front. I'm okay with that in the short term, but in the long term, let's get everybody programming. And again, one of the ways you do that is meeting the way that I just mentioned before, where if someone who doesn't feel very comfortable programming, if they set aside a specific time to do that and someone else joins them virtually or real, if you're able to do that in a physical space, then you're there to, when they're having confusions or troubles, you're there to help them out. That's teammates help each other out. But once you decide what people do, and I'm going to focus on the programming people, there is a description among the team as to what it means to complete that job. And the topic for today is software quality assurance. How do you know that that code was completed at the end of the sprint? I'm assuming that the code is completed at the end of the sprint. How do you know? How does the team agree at the end of the sprint that the code was actually completed? Here's how. You agree up front during the sprint planning meeting. Now, we've talked about requirements and test cases before. Where do you fold these into this process? One way to do it is to try to get all the requirements up front. But another way to do it is at the sprint planning meeting. If someone picks up 2 programming tasks, then during that meeting, they can say, because the team should be asking, right? How do we know when you're done? And so you can say, all right, I'm going to put this one requirement on this, or maybe 2 requirements on this programming task, and I'm going to make these 3 test cases. And you can do it as part of the meeting. Everybody agrees up front. And as soon as the code passes those tests, that code is considered done. And since everybody agreed to that up front, there's less confusion about what that code is going to actually be doing. So now you can fold in your, not just here's what the people are doing, but here's a very reliable, fully fleshed notion of whether or not they pass, whether the code passes or fails in its intention. That's what requirements and testing is for, right? So now your sprint planning meeting, and I said early on, I would put 2 hours aside for your sprint planning meeting. You're probably going to do your task allocation, like you said, about an hour. I think as your teams get better at that, that's going to be a half an hour. And then you might spend another hour on, okay, requirements in test cases. And again, in a real world situation, you have lots more requirements in test cases than I'm going to be asking of you. Do I have a specific number? No. Give me some quote, good coverage of your code. So maybe every user story has at least one requirement, and each requirement has at least 2 test cases. There's better ways to do that. In a real world situation, you would have many requirements, many test cases, and there are real life corporations where you are not allowed to start coding until your requirements are approved and your test cases are approved by a review committee. That's pretty formal. So instead, how about we can be a little more informal? Even the team might say, you know what, that user story doesn't need a test case, or that task doesn't need a test case or a requirement, but this one, we really want to have a requirement. Does this make any sense? Is there confusion as to what I'm saying? Does it sound like a lot of work? Yeah, it is. But let me tell you, when you are producing code, would you rather be the person who's producing code where you know what your requirements and test conditions are ahead of time? Or do you want to be producing code and saying, man, I hope this is what the team wanted me to do? Which person do you want to be? That's the payoff. Because every now and then, you know, we're human, and you hear things one way, someone hears things another way. You start producing your software, you're showing it during your product demonstration, and the rest of the team is, what are you doing? None of us wanted that, right? Okay. So all of these things are about getting invested in the process. And because it's a virtual setting, I really think it's tough. It comes down to, you know, really committing to, not that this course is supposed to take over your life. That's not the goal. Project courses, as you know, have that habit. Programming, as you know, has that habit. But bringing some discipline to the process in such a way that you can participate and understand why you're participating and be committed to it. Some of you guys, all software courses are this way. Some people feel very weak in their software coding skills. Some people feel very strong in their software coding skills. I tried to mix the teams up a bit so that if you are someone who is more experienced in programming, by all means, the less experienced people should be asking those teammates for help or advice, or, you know, at least pointers as to where to go. That doesn't mean that the strong, more experienced software people produce all the code. That's not what that means. And it's, you know, you have to stop yourself from taking over. Okay. Is it time to move on to course material? Do we have any further questions about this discussion before I go on? Okay. Let's see, we're going to do this quality assurance. So we talk about testing, requirements and testing. Quality assurance is broader than that. There are more forms than testing. Here's our outcomes. And as usual, I took Ochoa's notes, but I rejumble them. I'm present them in a sequence that I think makes sense to me, at least, and then add some parts. So some of this will fly through because the testing stuff we've talked about before, but some I want to harp on. So what's the deal here? First of all, software. This is all the motherhood stuff to motivate, right? We all know this. Software has become critical. You guys didn't grow up in the 60s, but you would be shocked to know that when your car broke down on the side of the road, you might have to walk 2 or 3 miles to a gas station to use a payphone instead of just reaching into your pocket and pulling out your cell phone. You know, things were very different then. When you wanted information, You went to a place called the library and you went and looked at books because there was no such thing as an internet. Right? So radical changes. And as you know, there's all the good and bad that comes with that. Right? So software engineering, quality software on time within cost. Pick two. I like this chart. We've seen it before. How many ways can we mess this up? If you look at this Venn diagram, desired behavior, meaning that's what the customer wanted, implemented behavior, meaning that's what you did, specified behavior, meaning this is what was put into the requirements documents. So the customer desires stuff, and then look at that section between desired and specified. If it's desired and specified but not implemented, well, heck, the customer wanted it and they specified it. That's what that overlap means, right? They wanted it and they specified it, so it's a requirement, but it didn't get implemented. In other words, you did not meet a requirement. So if you look at that Venn chart, there's all the different ways that you can screw this up. And the only part that is right is in the middle there, which is the smallest area. So there's plenty of ways to go wrong and a narrow path to go right. It's a nice chart to have. I should hang that up on the wall. What is software quality? So again, different views of what quality is. Some people are going to push the view of it's maintainable. Some people are going to push the view of it meets the customer's needs, or it's user-friendly, or it's reliable. You know, reliable software has to do often with things like a thermostat, right? It's supposed to keep the temperature all the time. It's not supposed to have much downtime. Or even messaging boards and news boards and things like that. Those or Ernie, scheduled maintenance Sunday at 10 o'clock. Well, what's that about, right? That's a reliability measure. How often is it available to you? Some people worry about how it was developed, blah, blah, blah. So we have quality of the product, quality of the process, quality related to the business environment, which is how does it actually fit into the business needs. I'm going to fly through these. You can read them. IEEE description and a Pressman, an author named Pressman description. So IEEE is really focusing on functionality, right? Did it meet the requirements? But if you think about it from a business standpoint, we should always think in terms of deployment and maintenance, and that really doesn't meet those needs so much. So there might be some more stuff that you would want to think of in terms of software quality. We're going to stick to the narrowest sense here, right? The broader sense is, was the process by which you developed it efficient? Was it cost efficient? Was it time efficient? Is it maintainable? These are the larger measures. The narrowest is, did you meet all the requirements? Lack of bugs and low defect rate. So anything that's an error in the software, we're going to call a defect. And from there, the rest of this will mention defects a fair amount of time. I'm going to come back to this verification and validation slide. No, I'm not. I'm going to talk about it right now. These are two good terms to know, verification and validation. Validation is, are we building the right product? In other words, you're validating against an external thing. Verification is internal. Are we building the product right? So just swapping those two words around means two very different things. Are we building the right product? How would you guess? How would you know if you're building the right product? That's the validation question. How would you know? How do you validate your product?
Talk with the customer.
Talk with the customer, that's right. And if it's one of these things where there is no customer per se, like, you know, nowadays people are putting games together and throwing them up on the game stores, and anybody can download them, right? Any of you guys can make it, upload it, download it, or on GitHub, right? There's no quite customer per se. How would you validate that? That's a weirder one. How about checking into market needs, doing
if it matches the software documentation?
Pardon?
Could you validate it to match the software documentation and requirements that you laid out?
So the validation is really actually what should the requirements be? Yeah, so it's even before that stage. What should the requirements be? Well, heck, if I'm building a game for myself that I put online, and I hope everybody goes and loves it and goes viral.
I guess the first step.
You're really just trying to go ahead.
Would it be then what you want the game to be, or what you're planning on coding?
Right. And if you're hoping to get a big hit, what you would do for validation is, before the fact, you would look around in the gaming markets and see what's popular, and try to establish what a need is, right? Just try to find a need. Now, that's not a customer per se. Normally we think in terms of a customer came to us with requirements. Once you decide what you want to build, once you know what the requirements are, then the verification part is, did you build it right with respect to the requirements? So validation is all about validating to the external world, and verification is verifying internally, did we build it right? So once we have a requirement, the software shall do this, and the verification is the test cases that shows that requirement is met. Now, that requirement still could be wrong, right? Unless we didn't, if we didn't do the validation right, that requirement still could be wrong. But the idea is, the verification is, did we build it right? Meaning the way we thought it should be built. Validation is, how do we think it should be built? And I throw in here this modeling and simulation community use of the terms, because several teams are doing simulations, and validation and verification has a similar meaning there, where validation goes to the external world. But in the modeling and simulation world, you validate your model against real world data. So for example, if you every time in hurricane season in Florida, we see these models of the hurricane tracks, where they're predicting where the tracks go. How would you validate that? Well, you watch where the hurricane actually went to see if your model was right. And because you have historical data, you can validate against all of the known paths of the previous hurricanes and see if you can come up with a model that can actually do good prediction. And then verification is, did we actually build, once we have a good math model in our simulation that is validated against the real world, then the verification is, did we actually build it right? Again, did we meet our requirements? So I only mention that because several teams are doing simulations, especially like a disease spread simulation. And if you really wanted to do one that was validated, you would match against real world data or other models that have been matched against real world data. Okay, so we want to get software to meet its intended use. And of course, we're humans, and what are you going to say? So software engineering, as I've said before many times, is unique, almost unique. It's different than the kinds of engineers that build physical things. So you're building airplanes, bridges, motors, mechanical parts, hinges. You have tools that software engineers don't have available to them. All the software engineering is, we're dealing with the invisible, the non-tangible. Electrical engineers, I would say, you could argue, are in the same spirit. They build physical things, but their behavior is not tangible. So here's the thing. If you're a civil engineer, you can build a 1/100th model of a bridge and test it, and then you can scale up the results. And you aero people, are there aero people in the class right now? What's a Reynolds number?
It's weird.
So a Reynolds number is a number that's used in wind tunnel testing, because when you're in this little tiny wind tunnel with a little tiny model, you want to make sure that it will scale up to the real thing, and you match the Reynolds numbers. So the aero people have a way to scale things up. The mechanical people have a way to scale things up. Some of the toughest things to scale up, it turns out, are aero and hydro, and the interaction between the two. So I'm sure you've seen those big long models of tanks of water, and they take ship models and they drag them along the water and record how the wake goes, or they put waves in there and watch how the ship responds to the waves. You ever seen those, like on Nova, on some documentaries? And they have ways to scale that up in a reasonable way. It turns out, though, that's pretty tough to get. Air is tough. Any kind of fluid is tough. Air is a fluid, it's tough. Water is a fluid, it's tough. Air-water interactions are tough. You know what's tougher? Software, because there's none of that stuff. It's all magic, it's all invisible. So how can a software engineer if you built a 1/100th model of your software, you know, how do you scale it up? What does that even mean? There are some limited examples where you might be able to do that, but maybe not. Maybe with a gaming system you play with 1/100th of your full, your online gaming capacity, 1/100th of your full user load, and, you know, track lag and stuff like that. But in terms of software, if I build 10 lines of code, does that mean that by the time I finish 100 lines of code, I'm correct? It doesn't make any sense. So it's tough. It's tough stuff. Okay, error, defect, and failure. There's an error led by, is what the human does, right? The human programmer is the one making the error, which injects a default in the software, which results in a failure of the system. So there's the human screwing up, which leads to the fault, which leads to the failure. And you've seen these things before, so I won't spend a lot of time on them, but basically, where do they come from and what do they cost? Where do they get these numbers, by the way? Most of these things are actually bad requirements. And then the next one is bad design, and then code. Well, what does that mean? When did you probably find the problem, though?
When you were coding?
You probably found it in the code when you were testing the code. And when there was an error in the code, then you would say, well, wait a minute. I followed the design, and then well, wait a minute, that must mean the design was wrong. Well, the design followed the requirement. So even though that's where they're introduced, that doesn't mean that's where they're found. And unfortunately, as you know, the further down the path you find it, the harder it is to correct it in terms of time and money. So if you fix it at the requirement stage, it's cheap. If you fix it in the design stage, it's like 5 times worse, coding stage 10 times worse. And God forbid if you actually put it out the door and deploy it. Which, by the way, you always see, right? Microsoft announces a new patch. And so here's our big new thing. Okay, now here's the patch, and the patch, and the patch, and the patch. All right, I think we all agree software is important and quality is important. There are some that are critical. So for example, if you're doing something like, let's say Excel or Word or something like that, you know, a big product that you want to sell to people, the cost of failure is that you don't sell because you got a lousy product. But some of things are worse. You know, if you do the bad aviation system, people die. If you, what did we have? Here's some examples coming up. You have a bad air traffic control system. You have a bad autopilot. 300 people dead. Look at the 737 for Boeing. Been grounded for a year. I think they finally got him back up. This was a combination software and unethical behavior on Boeing and maybe the FAA's part. But it was all software that caused those 2 planes to crash. People die. A lot of software has health issues. So you have a pacemaker in somebody, you probably want that pacemaker to be highly reliable and correct. So nowadays I'm seeing all these commercials for insulin monitoring. That's software, and it better be right, and it better be reliable. So you start getting things like that where people die. That's a problem both ethically and financially, because when people die, their families tend to sue you for all you have. Here's just a nice list of, everyone likes the horror stories, right? I don't know if y'all heard of the Vincennes incident before, but the Vincennes incident was, there was a civilian airliner that was taking off from an airport, and they were flying out over the, is it the red? No, it doesn't say where it is. In the Gulf, you know, where all the oil is in the Gulf. And the USS Vincennes saw that, thought it might have been an attacking aircraft, shot it down. Why? Software error. Patriot missile failure. That's, I don't remember that specific incident. London ambulance service computer aided dispatch system, people died because of bad dispatch. June 30th, 1980, almost had a nuclear war. I don't remember that one per se. I do remember when the entire West Coast network went down because someone swapped negative signs in a router. The busier the router it got, the faster it thought it would be, and it tried to absorb all the traffic from the West Coast. First operational launch attempt of the space shuttle. By the way, the space shuttle, I worked on payload integration for the space shuttle for about 10 years. And there were a lot of times where a launch would start to go and, you know, right a few seconds before liftoff, it was, okay, shut down, try again tomorrow. And usually they were software issues. Often they were software issues. They were certainly detected by software issues. Some of the more famous ones, the Vincennes incident was a really big deal. Ariane 5 explosion. I remember that, 1996. It was just a slight software error. Look at uncaught exception due to floating point error. How many of you guys have had that error on your code? You get a arithmetic error, you know, your program crashes and you're like, oh, well, you know, think about it with a
relatively common conversion error.
You know, yeah. So think about it with, okay, I just blew up a rocket. You know, and by the way, that thing was carrying a payload. That payload was expensive. I remember this one for sure. Mars orbiter disappeared as it began to Mars, and it was a difference between units, imperial units versus metric units. Yeah, 125 million. That was cheap. That was cheap. Mars polar lander. Poor Mars. These missions disappeared during landing on Mars 1999. Same problem, software issues. So software quality assurance really does matter. Now, we've been talking about, usually we talk about testing. So I'm not going to go through the testing too much. You know, I'll fly through those, the part 3 of this. But we usually don't talk about static verification. Now, what's static verification? What's the difference between static and dynamic?
Changing versus staying the same.
Changing versus staying the same, right. So when you're looking at static code, it means you're looking at the code, and again, I'm going to talk about in my day, on paper or on the screen, not executing the code. The dynamic verification is anytime you're executing the code. What kind of stuff can you do statically? Oh, surely not much. Actually, you can do a lot. And there are tools out there that will ingest your code and perform analysis on it and tell you about dependencies and tell you estimates of how good or bad your design is based on some complexity measures, things like that. That's all static verification. You really can build software whose job it is to take in other people's software and do analysis on it. That really is a thing. But most static verification, I would say, is done by people reviewing other people's work, reviewing your requirements, reviewing your test cases, reviewing your description of the product, and reviewing your code. All of that would be static verification. And review processes are important. I've got my, there we go. So you have static and dynamic. The static can be inspections, reviews, walkthroughs. Basically, it's getting another set of eyes to look at the stuff. That's what it's about. Whereas the dynamics is testing. And here I mentioned black box and white box. White box is where you know what the internal code looks like. And so you're able to construct tests in such a way that you want to examine the value of certain attributes or variables at different points in the execution. Black box is where you treat the whole thing like a black box. You're looking at input, output behavior only, what we call observable behavior, observable input and output behavior. So static verification, anytime you check in a review or a walkthrough, in other words, you get other people to look at this stuff. I like that line. There's no agreement on the meaning of these terms. I'm just going to call them all software reviews. My experience working in industry is you spend at least a third and maybe up to half of your time not doing your own work, but reviewing other people's work. That's what engineers do. Engineering is a lot about review, check, verify. And again, look at the stakes. If I have a someone designing a wing, the main spar on a wing, and they're saying, okay, this will take this aircraft is designed to take 5 Gs. I designed this spar to take 6 Gs, and everyone's like, we trust you. That's not a good way to go. So they don't trust you. They review. I spent a lot of my time when I was in St. Louis. I worked on a satellite components. I was doing the structural analysis, to make sure they wouldn't fall off the satellite. And all of our avionics boxes were produced by another company, and they would submit a report on each box explaining to us why that box was structurally sound. And it was my job to read through the report, duplicate the math, convince myself that the assumptions were good. You spend a lot of time reviewing other people's work. And then our engineers would draw drawings, and 4 people had to sign off on the drawings after reviewing them. You always had the designer himself, a structures person, a thermal person, and the chief engineer had to sign off on all the drawings. So you check, check, check. And then once we were done checking, we would present to our customer and they would check. And still things go wrong. So be aware of that. Meetings, software review. Meetings are in which your software artifact is reviewed by other people other than the original developer. It's a really good idea to have other people involved. In fact, you might even invite people who are not on your team. That's one of the reasons I hope you guys get to meet with the TA/customers as often as possible. Your goal is, notice, is to discover the problem, not to fix them. Why not fix them? Why wouldn't you fix them? What's that about?
Well, that comes later on at a different point, right?
Right, right. It kind of goes back to my agenda talk, right? The agenda is we're going to review and see if we can find problems, and then fixing them. That's a different thing. If you try to fix a problem, that's going to be, you find one discrepancy, you find one defect, or you find one thing you're not comfortable with, you try to fix it. And guess what? That's the only thing you're going to talk about the whole meeting. And maybe longer. Some of these get into pound on the table kind of situations, right? So here's my question. Is your team reviewing software? Yeah, it's great. You assign these software tasks to people, and then they go away and they produce the software, and then they come back and say, yeah, I did that, and it works because I checked it into the main code on GitHub and it all ran. But did anybody actually look at their code? When would you look at their code? Think about how your team wants to plan for that stuff. You're not going to get full coverage, right? You're not going to get 100% coverage of everybody's code and everybody's other artifacts. But how do you do this? How is your team going to do it? Don't answer that question right now. I'm identifying the problem, so we don't need the solution. But I want your team to be thinking in those terms. Now, let's pretend you were doing Agile Scrum in a corporate setting where you actually were in a co-located team. And then how does Agile Scrum incorporate reviews? Because remember what Agile Scrum said? They said, I'm going to shut up and let you guys talk in a minute. Agile Scrum says, we don't want documentation. We don't want all these heavy processes, right? We think that working code is more important than documentation and processes. We think that interrelationships between team members is more important. So how does Agile Scrum incorporate reviews? Do they just ditch it or what?
Is it the sprint demo?
It's the sprint demo, right? That's one form of product review, right? You do a sprint demo with the demonstration, and you're demonstrating to external sources. What else? Anything else? It's that co-located team. If you guys truly were sitting in the same room, all working on stuff, and here I am, I'm writing code, and I write, 50 lines of code or 20 lines of code. I might say, hey, come and take a look at this. See if I did anything stupid here. So you get the co-location, the review process, at least internally, happens automatically or osmotically, as long as everyone's open about, okay, It even starts out with, okay, I need to do this here. I'm thinking of this data structure. I'm thinking of such and such. And you're drawing it out on a whiteboard and everybody's looking at it and they get to say right off the bat, it's really a review. Oh, that's a good way to represent the data. Or you're going to have trouble with this or trouble with that. Or what if we need to expand to this, right? Everybody gets input. So there's no, within the team, necessarily a formal review that takes, like, this is a separate meeting, we're going to our review meeting. It happens continuously. Now, for the external eyes, right, there's a sprint demo. And at the demo, by all means, the customer can say, show me your code. I want to just glance through it and see if it makes sense. And of course, everybody does Agile Scrum differently. So you may still have in a corporate setting an honest to gosh review session for the requirements before you start creating code, the test cases that are often written before you start creating code, and then the finished code. But think about it. What is your team doing to ensure quality? Don't answer me here. Think about it. Talk about it with your team. Why are we doing these reviews? Combined knowledge, right? Two heads are better than one in theory. As long as they have this, the different viewpoints. What is, what's the word? What is groupthink?
Is that where like nobody thinks for themselves?
Right. Everybody has, right. So if you get into a group, and this happens in corporations, you get into a culture and, you know, they kind of indoctrinate you a little bit. Hey, you know, here at Boeing, we do so-and-so and we do it this way and we do it this way. And that's all great. You need that. You need processes, but you can also get a kind of a tunnel vision or a group think where everybody thinks along the same lines. And every now and then it's good to have an outsider come in and say, yeah, but what if we did it that way, and really shake things up. So the different viewpoints actually may be easier for people to find who aren't so closely tied to the product itself. This is, by the way, a really good thing to, I don't know if you've noticed this, but when you come up with a really clever solution to something, or you are thinking about you know, a software project that you're doing, or maybe even a report that you're doing on another class, and you're like, oh, I'm going to do this topic, blah, 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 and I'm going to talk about this, 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 and this. Tell somebody about it. And they have the habit of asking really annoying questions like, well, why don't you want to talk about that? Or, you know, are you sure that needs to be in there? Or will your software do this? Will your software do that? That's really good stuff. And sometimes people who are really outside the knowledge domain ask really good questions because they force you to explain things. Why can't I do so-and-so? Well, the reason you can't do that is because of X, Y, and Z. Well, why is that way? Well, the reason X is there is because of A, B, and C, you know, and you have to, you know, you have to explain things basically from the ground up. That's good. That's a good thing. You know, how do you know when you know something? If you can explain it, that's a really strong indication that you know it, right? If you can teach it, that's a strong indication that you know it. And I don't say that as a conceit on myself. Finding flaws early, right? You want to find them early. So ideally, if you guys are saying in your sprint planning meeting, if you're saying, okay, here's the task, so and how do we know when we're done? What's our metric for doneness here? Then you might find right off the bat, oh yeah, we hadn't thought of that, right? If you have to write a requirement for a task that defines the doneness of it, and there's 4 of you, then that might be better because someone might come up with something that the person who was actually assigned the task said, oh, I hadn't thought of that. Well, awfully good to let them know before the 2-week sprint starts than after the 2-week sprint ends. And the same is true for documentation. Oh, I'm going to put in the description of the product. Okay, what needs to be in there? Ding, 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 right? All these topics need to be addressed. Oh yeah, I hadn't thought of that. Okay. It makes the work clearer. In theory, reduce rework and testing effort. By the way, it can be hard to sell that line It reduces rework and testing effort. Doesn't it sound like I'm asking you to do more work? How can it actually reduce work overall? You buy into it? How, if you were a manager and you had to pay for time, well, how long would you let people do planning and work before they started coding? You know, at some point, once you get antsy that there's no code being written, why is it a hard sell?
Would it be because the benefits of those, you know, quote unquote, not, you know, not coding, not quote unquote productive pre things, I guess, isn't seen until way later?
Yes, and I'm going to go one step further. They're not seen at all. How much did you save by not doing work? Well, we don't know because we don't have a yardstick. So if I spent 100 hours on a project, how can I prove that if I didn't do it the way I did, it would have been 140 hours? I can't prove that. This was our industry motto. And when people are paying you money by the hour and you're not developing code, it makes them nervous. Yeah, but I'm going through this, right? And there is a correct balance, a magical balance, and you know, nobody ever knows where it is. Now, the idea behind Agile is that you jump into the code development right away. The good news is you can respond to change. The bad news is you may have made some poor decisions up front. I gave you all the only a 1 week pre-sprint time period. I think that was too short. I think that should have been longer. So, you know, if I do this class again, I would adjust that schedule, because I think you need a little bit more time up front to plan stuff out and to start to gel as a team. Review versus testing. One of the things that reviews will work out well with is not just is the code correct, but is the code, quote, well written, right? Is the code understandable? Is it clear? Did you even choose variable names that make any sense? Are you using data structures that make sense? You know, people might be saying, oh, we don't know. In the future, we might have to do something else with this software. So, you know, how can we protect ourselves so that we don't have to, you know, redesign from the ground up? Oh, well, if we go with this route, it turns out we can, you know, branch off pretty easily and use all the same data structures. You can use the same classes or something like that and extend them. So you have this notion of not just correctness of the code, but the larger sense of quality of the code. All of your SDD, your software design documents, your description of the product, description of the problem, description of the product, description of the design solution. These are things you can't execute anybody. So you should have not just somebody writing your documents. You know, everyone should be contributing, but you know, some form of review in that too. Now, if everyone's contributing, the goal is it's self-reviewing in the sense that if I do section 2 and you did section 1, even though I'm responsible for section 2, section 1 and section 2 need to play together. And it's supposed to sound like it was written by the same person. So I'm going to go through and make sure that what you said was, you know, and oh, and by the way, I might find while I'm writing section 2, I need to use terms that were introduced in section 1. And if they weren't, then I can go back to section 1 and introduce them. Collaborative writing is an interesting thing, but it's possible. Now, these things are tough, right? These things are tough. What they're saying here is 1 hour IBM, 1 hour of review saves 20 hours of testing. What they're saying is if they found a defect, they know from experience that the likelihood of what that defect would have cost them, because they found a bunch of defects before, right? So if you find a bunch of defects, you can say, okay, each defect tends to cost us this much. And so if you find one in planning, you can say, oh, we saved that much. It's still a hard sell. It's still a hard sell. This rework, now the one with Raytheon, that's a real thing, right? Reduced rework from 41% to 20% of cost. Hopefully that means the rework effort went down, not that the overall cost went up, right? We can interpret that two different ways, but hopefully that means the rework went down. How do you make that work? Again, it's a hard sell. What you have to do is with your management, or if you are the management, you can do it top down, but you might say, okay, we want to try this new method and we're going to be an experimental group working this method. And now we're going to say that we can compare our performance of the group compared to previous processes that were used in the corporation. More industry examples. Now, again, there was no, I'm going to treat all these things as reviews. So the walkthrough here, I think all of you guys are going to have relatively informal reviews. That's okay. The point is to have them. Even your demos that you're giving to the customers, relatively informal, in in the sense that there's just not enough time to go through a lot of detail with everything. Inspections, formal, technical, okay. Inspections tend to be actually done by external people, literally inspecting, right? Sometimes, and there are people who work in industry called inspectors. Generally, they're referring to mechanical things that are being inspected, but they can also be test inspectors. So if you have a test document that says do steps 1, 2, 3, 4, and 5, and you check off that you did steps 1, 2, 3, and 4, and 5, on the bottom of that page is going to be a little place for an inspector stamp, and the inspector will watch you do steps 1, 2, 3, 4, and 5, and then put the stamp on the page. And I will tell you, they are very stingy with that stamp because that's their reputation and their job. If they stamp something inaccurately, kind of like a notary, right? They will get in trouble. They can lose their job. So they're very stingy with those stamps. Again, I don't think y'all will do the formal stuff too much. Okay, review types 3. I think this peer desk check, that's a good one for you guys. I think if you can try to work in the same virtual space, even though you're doing one thing, another person's doing another thing, but periodically it's like, okay, I wrote this paragraph, give it a read, tell me what you think. Right? Just a quick turnaround like that. I think that would be a good thing if your team can pull it off. The next best thing would be the asynchronous. Pop it up to Microsoft Teams or OneNote or GitHub or wherever, and then ask people, tell people you put it up there and say, please review it. And, it may be that people can only do a quick review of it. Better than nothing. What to review? Oh, everything. Nothing can escape review. All right. I'm flying through this a little bit because, again, you can read these things. If you have questions, stop me. When to review? As soon as possible. I'm going to skip through that. I'm going to get to the payoff here. Who are the participants? This one's good. Who are the participants? Okay, the moderator. All meetings should have someone who's kind of in charge of what's going on. The author of the work. Well, they have to be there to describe what's happening. People are going to have questions, right? Answer the questions. And then the reviewers themselves. Again, it should not be the author, and it shouldn't be necessarily someone really closely tied to the product. So I'm asking your team to do your own peer review, but be aware a better review would be if you could con someone from another team into looking at some of your stuff. But that's the goal, again, of what I'm hoping the TAs are doing. And if they're not, work with them to make that happen. And I'll work with them to make that happen. Okay. You want that alternative viewpoint. You want fresh eyes on this stuff. And you want some record that things happen, right? Again, if someone reviews it and says, oh, you should do this, this, and this, but you didn't jot it down anywhere, that's not helpful. You know, you need to make a note somewhere. Not full board documentation, formal meeting minutes, that kind of thing. Not a bad idea though. Have a meeting that you tag that you had that meeting somewhere, you had a review session somewhere, and you know 3 things came out of it or something like that. But try to find that blend that works for your team between documentation and action. If you have the review and they tell you 3 things, you'll forget what the 3 things are. Put them down somewhere as action items or tasks that go into the next thing. Okay. The planning is the tough part. I think this is where really the sprint retrospectives come in. Well, the sprint planning meeting obviously comes in for the tasks of the sprint, for the sprint. But what about planning how you're going to do your reviews? That's a great topic for your sprint retrospective, because what's the goal of the sprint retrospective? What do you want to get out of that meeting? Improvements to your team process, right? And that would be an improvement to your team process, or at least a change in your team process. You can think of every sprint as an experiment. You're experimenting with how your team works together. And at the end of that 2-week process, you assess the results of the experiment. What worked, what didn't. By the way, really good things to jot down. So that when I'm looking at, you know, hey, what is the team doing? From a grade standpoint, I can look at some document. You know, I don't need voluminous meeting minutes, but some kind of meeting minutes. Okay. I'm getting to, there we go. Okay. So what can go wrong, or what would make this go well? If you're doing a review, you're participating in a review, what are the pitfalls here? What can get screwed up? What would make the meeting non-helpful as opposed to helpful? Here's a couple guidelines. Number 1, you're the author of the work. Someone is reviewing your work. How do you feel? How do you respond? How do you feel?
Hopefully you can accept criticism.
Yeah, right. So the natural human thing to do is be defensive. You spent all this time on this code. It's your baby. Oh, they're attacking my baby. No, they're not. They're improving the product. Improving the product. You spend a bunch of time writing some beautiful description of the product in your software design document. People don't like it. They're improving the product. So as an author or an owner of the product, your attitude should be try to put your ego aside and try to accept that the product that you created has flaws and can be improved upon, and that if other people improve upon it, that's just as good as if you improved upon it, right? It doesn't have to be, it's not like in football, right? I want to score the touchdown to pad my stats, right? It doesn't matter at the team level who scored the touchdown. It only matters to the individual, right? They want to pad their stats and get more money next year in their contract. It doesn't work that way, right? You make the product, it doesn't matter who improved it. The goal should be to get it better. Now, from a reviewer standpoint, what are ways to screw that up or make it work right, make it work well?
I found for me, it's hard to know, like when I'm reviewing other people's stuff, it's hard to know like where to stop. So like coming from, I haven't taken many software classes, but I have done software in the industry. So I found that I can like just do the most, and like sometimes that's too much, you know?
Yeah.
So like,
So
yeah.
in what sense? In tearing down the code?
No, just in that like trying to make the document be more like complete than it needs to be at a certain point.
Right. And it's a tough balance. It's hard to make a document too complete. However, and I say this from an instructor standpoint, I recognize this is one of 4 or 5 classes you are taking. And so there's a completeness criteria that is reasonable for a course as a, you know, an academic setting, as opposed to a real world industry setting. You know, in a sense, we're simulating things here, and simulations are always approximations. So I would love it if everyone had, you know, a big, thick requirements document and a bigger, thicker test case document, but that is not a reasonable expectation. And that's where I think how I relate to what Rose is saying. I want to have you guys understand what completeness looks like without having the burden of having to go through all of the steps. Go through the steps enough times to show me that you know what completeness looks like. And that's a hard line to draw. So as a reviewer, and my sense as a grader, you know, I have to temper what I expect in terms of completeness. Now, what is there? I like to be accurate and concise, and that, you know, all of those abilities that go in there. Okay, so drilling down into too much detail may be one way to go wrong. That would go wrong partly because the meeting may not be productive. If a reviewer insisted spending all this time on this one little section when we've got this much stuff that's supposed to be reviewed, and the reviewer won't let something go, that could be a problem because it bogs down the meeting. What other ways can we screw this up? Let me ask it this way. Is the review a confrontational or a collaboration? Is it a confrontation or a collaboration? Is it cooperative or confrontational?
No, it should by all means be collaborative.
Absolutely. And what does it often turn into if you're not careful? Confrontation. So both parties have to come to that. The author has to come to it and say, I am not defending my work. I am explaining my work, right? So when people have questions, I can explain the work, and you may even refer to it as the work instead of my work, right? To emotionally detach yourself from it. But again, this is not my baby. I'm not defending my baby. These people are here collaborating with me to improve the product. And from the other point of view, it's also the same point of view, the same mindset. You are not there to try to prove how much smarter you are than the person who produced the product. You are not there to try to diminish the person who tried to produce the product or diminish the product. You are there to try to improve the product. So number one, you're going to direct your comments to the product, not the person. Right. And you're going to stay away from judgmental terms like, my God, what a stupid way. I've never seen anything so stupid in my whole life, right? That is not going to encourage collaboration. Right. So there's going to be the approach is more from the reviewer side. What I find is asking questions is, hey, what if you did this? What if you did that? What happens is this. Why is that there? Why did you name it that? Those are things that tend to, my phone is going insane here. I don't know what's going on. So approach it that way. Be careful. There, you know, as much as engineers are emotionless animals, you know, we are human animals, and we have emotions, and people will get, you know, will get frustrated and non-productive if people are coming in with the wrong approach. And you'll find those people. They're not hard to find. You'll find people who want to come in to review your product, and their hidden agenda is to show the room how clever they are and how they can make you look stupid. They're out there. You know, there's not that much you can do about that. They exist. If they are actually giving you improvements, hopefully you can set the insulting part aside and accept the improvements. Usually those people, everybody else in the room knows what they're up to, and you know, doesn't give them much credence anyway, other than if they have an actual good idea. Sometimes people want to just put their stamp on things. They just want to modify something just to say, I contributed. You know, that's the benign version of the previous example. If I go into a meeting with a review and I didn't say anything and I didn't bring up anything, I might feel like, man, I didn't really contribute to the product. I should say something. So you say something, you know, just for the heck of it. That's a fairly harmless thing to do, but it's not always that helpful. It's okay if you go into a review session and you truly didn't see anything that you thought was, you know, really needed changing, or would benefit from changing, I should say. That's the thing to say. That's the correct answer for the review. Oh, looks good. Now, what if you would have been, oh, I would have done it differently, but what you did works just as well. You don't even need to mention that if you don't want to. That style choices don't have to be mentioned. So be aware, some of this can fall apart. If the basic attitude is we are all here to improve the product, then things go a lot better. And there's some slides about that, right? So you want to keep your team small. Your own team will be that 4 people, and then maybe if the TA and I are there, we're going to be up to 5, 6 people max. So you're doing pretty well. I would say also don't get bogged down if a reviewer says, you know, here's this, you know, why are you doing this? Here's an alternative way to do this. I have an issue with this. I don't think this was really the best approach, whatever. If the rest of the team is saying, okay, we can address that later, or we're taking that as input, but we think we're going to leave it the way it is, as a reviewer, you kind of have to let that go, right? And unless you have a super compelling reason why it shouldn't be let go, don't let the meeting get bogged down on things. Find the problems, don't try to solve them. Limit your meeting times. It's always good, all your meetings, put a time box on them. You will be surprised at how that works for productivity. Advanced preparation. It's not a bad idea. You can do this either way. Not a bad idea if you want to do, say, code review, to have the code available to people ahead of time. I think most of you guys, at least within your teams, your code is available 24/7. If you know you're going to do a review of the code, maybe the day before, take a look at it, or 2 or 3 hours before, take a look at it. And have a checklist. There's your agenda item, right? Have a checklist. All of your meetings should have some kind of an agenda or a bulleted list of here's what we want to get out of here. I say again, if you have not looked at the Scrum Guide recently, take a look at it. Okay. Once everything is, you come out of the meeting, all the action items are nailed down. People can address these things and follow up. I'm going to follow up there. This is the part I was talking about earlier. Be aware that engineers are people too. And so you need to take into account human feelings when dealing with these things. Okay, and then the testing, as I promised, I'm going to go through this pretty quickly. The main thing to get out of here is two things. Number one, software is not complete until it's tested. Number two, you cannot prove software is correct by testing. You can prove that it maybe is good, but you really can't, in the general case, you cannot prove all of it is good. Okay, so you cannot prove a program is correct by testing. Nor can you prove a program is correct by analysis. You can prove that the idea for the program is correct by analysis, but then how do you know the person who programmed it programmed the analytical solution correctly? So you cannot prove the program correct by testing. The only way to do it is to literally test all possible inputs. And as you know, those of you that took CS222, or at least took it with me, we have this thing called combinatorial explosion. Numbers, even in simple systems, numbers get really big really fast. How many ways can I arrange the books on a shelves? Well, it turns out there's 48 million ways to do that. Okay, that's 48 million test cases. That's a long night, right? So it's impossible to do this stuff. So what is your goal? Your goal is to do what we call get good coverage of the code. It's in what Dijkstra, this is a known problem, 1972. Program testing is a great way to show the presence of bugs, right? If something is wrong and you test correctly, you can find the bug. But you still can't say there are no bugs in the program because you can't prove that they're absent. You can only prove they're present. So that's the inherent problem with testing. Those of you that took CS332 with me, hopefully will remember from last fall that what was the bottom line with Turing computability? Turing said you cannot build a computer program that will take in another computer program and prove that it's correct. That analysis cannot be done. Therefore, we have to resort to testing. Oh, but it turns out testing can't prove correctness either. It can only prove that we pass the requirements that we tested for. That's all it can prove. But how many ways can that go wrong? Oh, this is too many test cases, that's the problem. But how many ways can that go wrong? It can go wrong because we didn't test for something properly, we didn't do our test case properly, we didn't do the requirement properly, right? There's all kinds of ways that even though we passed all the tests, the software can still be wrong. It's a dismal thing, right? This chart, by the way, is showing the kind of the old waterfall model, or you start out with requirement specification, and in this chart they assume that all of the requirements are specified at the beginning, and then all of the design comes in, and then all of the coding is done, and then the testing occurs. And so in that model, we're looking at the larger software systems, but this still applies to the way you do the coding in the agile sprints. And that's what I'm saying within your sprint planning meeting, requirement specification can become a part of that meeting. Time box it, right? So it's still a 2-hour meeting, but requirement specification can become a part of that. Or even if it's not, if you said to someone, okay, here's the code that you're gonna do. You're gonna do these 3 methods in this class. That's your task for this next 2 weeks. The first thing that person might do is not write code, but say, okay, I've come up with a requirement for each method and I've come up with 2 test cases for each method. Why don't you guys take a look at it? And then if you like them, I'll start coding. That is an okay way to go about this. And it fits within the agile methodology. Okay, I'm not gonna go through this chart. I think you guys, actually, I'm going to go through a little bit of this test chart. It turns out if we get into systems thinking, you build your things in units. Now, in your case, you're going to build, one method at a time, one class at a time, one component of your software at a time, and they get tested at the unit level. Then you integrate that into a larger whole, and you do what's integration testing. And then you get into functional testing, and we're going to stop there. We're going to stop at that box. But as you're building your software and you incorporate new stuff, even though you're doing functional testing, you incorporate new stuff, how do you prove that you didn't break the stuff that passed the test earlier? Well, that's what these automated testing suites are so useful for. It's called regression testing, where you're testing the old stuff over again. Even though you didn't change that code, test the old stuff over again. Automated suites have testing suites are great for that. You build in your test cases one time, and then every time you commit your code to the repository, before you commit it, you can run the test suites as JUnit testing on Eclipse. I think we talked a couple weeks ago that GitHub has an equivalent version that can be downloaded. Actually, it can't you add egit to Eclipse, and therefore you can get JUnit testing in Eclipse and use the egit with Eclipse too. So there are ways to do this. I recommend that we get into the JUnit testing. That would be a good thing. I don't think that topic is in this course explicitly. That should be in the tools module of this course. You agree with that? Does that sound right? Adding more stuff to the course, doesn't that sound right? And then you have to have some kind of an artifact. A word about that. I gave you an Excel spreadsheet to fill out, and it's probably not the best. I'm not happy with it. If you want to do an alternate form of artifact for your test plan, let me know and get approval from me, and then we can go with our alternates. What I need, though, I do need a couple things. I need the traceability matrix, so I know why that test is there. Where did it come from? Why are you doing this test? And I need to know who did the test and what day. The other part of that spreadsheet is about the input conditions and the output, the expected behavior. If you're using like JUnit testing, you're building that into those test classes, and it's okay to refer to those classes and not put those details in the Excel sheet. Okay, hour and a half turns our brains to mush, right? Unmush yourself long enough to have a question.
So if we were to submit like meeting minutes and stuff, would we just include that in the zip file with all the other documents?
Yeah, just throw them in there. And that's,
Okay.
you need to get a sense of how the team is working and how individuals are performing on teams. And that's one way that I get a little bit of a keyhole look at the team dynamics. Yes. They can be informal. I don't have a real requirement for that. Other questions? Okay. That other question on the bottom, what is your team's test plan? How do you validate and verify your work? That's for your team to figure out, right? You don't have to answer that here. These are things to take back to your team. And by the way, you're in the middle of a sprint, so guess what? You're kind of stuck, right? You want to bring those questions, by all means, you can introduce them to your team so they're thinking about it, but that's your sprint review, sprint retrospective, sprint planning stuff. That's where you're going to get some good discussion and resolution on this stuff, I hope. All right, other questions? Comments? Fears? All right, I'll see you guys. Team that's meeting at 5 o'clock, I will try to be there, but no promises. All right.
Is that our team?
Yeah, I think that's your team.
Okay.
I might have several, but yeah.
We usually just kind of meet like 5 minutes after this class ends.
Oh, okay. All right. Then I'll send, it's a Zoom. You sent me a Zoom link or
It's Discord.
Discord link. I'm already in that Discord team, right? All right. All right. I'll join you there in 5 minutes then.
Okay.
Thereabouts. All right. Okay. Bye, guys. Have a good rest of your day and week.
Thank you very much, Professor. Have a good week.
You too.